Okay, let's look at what happens when we combine functions and think about what happens with their domain. So first I'm going to go in and just investigate this function f of x is equal to the square root of 9 minus x squared. So 9 minus x squared, if I'm going to take the square root of that, it can be equal to 0 or it needs to be positive. So for the domain for f of x, I make that radicand positive. And then I'm going to try and factor this because I've got a quadratic inequality. So I'm going to find my critical values, and those happen when x is -3 and +3. So then looking at my values here, at -3 and 3, so I can test -4, 0, and let's say +4. So I'm just going to usually make a whole sign chart, but this seems easy enough just to plug it in and do it all at once. So at -4, I would have that squared, 9 minus 16, that's negative. And at 0, I would have positive. And at 4, 9 minus 16, again, that's negative. So we want to know, when is this equal to 0? Well, that happened at our critical values, and it can also be greater than 0. So it's this little segment here. So the domain for f is given by that interval from -3 to 3 inclusive. And I also have a square root for my g function, so let's look at the domain there. I'm just going to keep track of this here. Okay, so for my g function, I would take my radicand and make sure that it's positive, again factoring it. Key values there are at -2 and 2. And we just think about the sign at, we could say -3, 0, and 3. So I square my input and subtract 4. Let's see, here I would get 9 minus 4, so that's positive. 0 minus 4, that's negative. 9 minus 4, that's positive again. So we want to know when it's positive. Well, it's actually equal to 0 at those key values, and then it can be positive in 2 different sections. So we would go from -infinity to -2 inclusive, or from 2 to infinity. So that's the function, or that's the domain for g. Okay, now when I am combining these functions, so for example, if I need to find, I'm supposed to find f plus g. Okay, so that's not all that hard. We just take f function and add the g function, x squared minus 4. The domain is trickier though, because the domain says we need to have the domains be true at the same time for both A and B at the same time. So let's look and see what that would look like. Domain of G and domain of F. Well, let's see. Here, our domain of f went from -3 to +3. So when they happen at the same time, it's just this little section right in here and right in there. Okay, so those combined would just be from -3 to -2, or from 2 to 3. All right, so that's an important part of that. Okay, and then moving along, if we did f minus g, we would just subtract those square roots. And then let's see, f times g, we would take and multiply them, 9 minus x squared times square root of x squared minus 4. And we could simplify that just a little bit. We have a square root times a square root, so that would take and multiply our radicands. And then we could simplify in there, we can FOIL that out. I'm going to scoot this up a little bit. So we'd get 9 times x squared, so that's 9x squared. And then 9 times negative 4 would be minus 36, minus x to the 4th, and then plus 4x to the x squared. And just putting that in order, negative x to the 4th plus 4x squared plus 9x squared minus 36. Okay, and it's still, the domain is the same for all of these. We've got our domain for all of those. Okay, the thing that's different is when we do a division problem, we need to just make sure that the domain of G cannot equal 0. So that's just one extra thing. And in our domain here, we don't have, I'm looking at this domain, we don't have a 0 in there. That's not part of it. Okay, so we don't have to worry about that. Okay, so we'll go ahead and do our division. F divided by G, so that would be the square root of 9 minus x squared divided by the square root of x squared minus 4. And if we wanted to rationalize the denominator, we could do multiply both by the square root of x minus 4, 4x squared plus 9x squared minus 36 when we multiply those out in the front, or in the numerator, and then, right, because if we take both squared minus 4 and rationalize that denominator, then the numerator ends up being exactly what we got here when we multiplied our functions, and then in the denominator we have a square root times itself, so those square roots just undo each other. So we would be left with that function. Okay. All right, so let's look at composite functions. For this class, we're not expected to do the domain for composite functions, so we don't have to worry about that. Okay, the composite function, basically it's where you take and you input your -1 into the first thing that is, you know, that function closest to us, and then whatever that output is, you're going to plug that in as the new input for the second function. You kind of picture this. So this is saying first put -1 into that f. Okay, and out comes f of -1, and then that's going to go into the second function, which happens to be, in this case, f again. Okay, so what comes out is the composite function. All right, so let's go ahead and do this. So f of x takes, let's see, I'm going to give myself a little room. So f of x, what it does is it multiplies my number by 3 and then subtracts 5. So we take -1 times 3 and then subtract 5. So out comes -8. Okay, so that's now going to be my input that I'm going to put into my second f. Okay, and so that takes 3 times my input and subtracts 5. So this would be let's see, negative 24 minus 5 would be negative 29. Okay, let's try another one. So 2 is going to go into G. Whatever we get out, that is then going to go in to G again. Okay, so first we put 2 into G. What G does is it takes 2 minus our input squared. So 2 minus 4, that would be negative 2. Okay, so that's now going to be the number that we plug in. That was negative 2, and that goes back in there. Okay, so we take our function 2 minus input squared. So we take negative 2 and square it. 2 minus 4 would be negative 2 again. All right, maybe those were a little confusing just because I was doing the same thing twice. Let's try it when we have different functions. So I'm going to do f of g. Okay, so what this means is of x. Okay, so I'm going to take my g of x. That is square root of x minus 5. That's going to go as my input into f, okay? So what f does is it takes my input and squares it and then adds 1. Okay, my input now is square root of x minus 5. Okay, squaring a square root, that undoes it, and I'm left with x minus 5 plus 1. So I've got x minus 4 is my final answer. Okay, let's do g of f of x. Okay, so first I'm going to get my f of x, that's x squared plus 1. That's now going to plug in and be the input for my g. Okay, what g does is it takes my x, inside I take x minus 5 and then square root all of that. Okay, and so now my input is x plus 1. There's my input, and in it goes. And we don't really need parentheses. X squared 1 minus 5 would be x squared minus 4. There's that one. Okay, now we're supposed to do f of f and g of g. F of x. Okay, so my f of x takes x squared plus 1. Now I'm going to plug that in as my input to f again. Okay, so that is going to take my f, takes my input, squares it and adds 1, but now my input is x squared plus 1. So now I need to multiply that out. X squared plus 1, we'll just FOIL that out. Okay, so this, all of this is me simplifying that first part. So I'd get x to the 4th plus x squared plus another x squared. So plus 2x squared and then plus 1. And then we had plus 1 on the outside. That was from here. So that simplifies to x to the 4th plus 2x squared plus 2. Okay, we're almost done. We just need to do g of x. Okay, so my g of x, that output is square root of x minus 5. So I'm going to plug that in as my input now. Okay, so what g does is it takes, square roots my input minus 5. Okay, but my input now is square root of x minus 5. So we have the square root of x minus 5 minus 5. Ooh, that's crazy. And that's done. All right. This one, let's see. First, we just go from the h. That's going to be put into my g, and whatever I get there is going to get put into my f. Okay, so we're just going to start this. Let's see. H is this part right here is x squared plus 2. Okay, that's going to go in and be my input in G. And eventually then I'll have to plug that into F. Okay, so what G does is it square roots my input. That's G. So then now that is going to be inputted into my F. And what F does is it takes 1 over the input. And since my input is the square root of x squared plus 2, then there's my function. And just quickly rationalize the denominator. So we've got the square root of x squared plus 2 all over x squared plus 2. And that one's done.